The space in which we live, grow, run, or stand still is not as we have imagined it for millennia. The same goes for time. Albert Einstein demonstrated a little over a century ago that space fused with time, spacetime, can always deform, bend, contract, or expand, like all other entities of physics. This nature of space-time, that is, the fact that every portion of space-time is always curvable, has the fundamental consequence of the non-existence of the straight line. In fact, the straight line cannot curve, because by curving, the ends would coincide, which is contrary to the very definition of a straight line. Therefore, when we move in space-time, we always travel along curves, even when we believe we are following a straight line, which actually consists of a huge circumference. Einstein also demonstrated that it is the bending of space-time that causes and describes the gravitational attraction, the attraction between two crumbs or between two clusters of galaxies and between us all and the Earth, which, thanks to this, we can inhabit. The curving of space-time and the related generation of forces is a phenomenon that geometry has also demonstrated, and this double demonstration, physical and geometric, highlights how physics and geometry are never separable. But now, let's ask ourselves a question. Does the fact that gravitational force is generated by the bending of space-time have any important geometric and physical consequences? The answer is yes, if we think that there are other forces of nature besides the gravitational one, and that these forces too, as physicist Theodor Kaulitz pointed out many years ago, must be generated by the curving of space-time. You will then agree with Kaulitz that also the other forces of nature, that is, electromagnetic force and the nuclear forces weak and strong, had to necessarily be generated by the bending of space-time. The phenomenon is somewhat reminiscent of that of the air, which undergoing different treatments generates different sounds. Similarly, different conformations of space-time generate different forces. Returning to Kaulitz, a long search for those mysterious conformations began, the search for the unknown dimensions configuring a space-time that seemed elusive and that nevertheless had to exist. It was a work that engaged for many decades not only Einstein and Kaulitz, but many other physicists, because the solution of this enigma was really important. In fact, it would have resolved the gap between the physics of general relativity, the nature of the macrocosm, and quantum physics, the nature of the microcosm. From then until now, this enterprise has been massively tackled by theoretical physics, but without achieving any results. On the other hand, geometry, before now, had never bothered to prove the curvature of space-time, nor does it seem to have ever bothered to look for where the unknown dimensions were, those dimensions whose bending generates the other forces already known. If it had done so, it might have discovered a long time ago that these dimensions, anything but hidden, as some have claimed, were and always are in front of our eyes. How to know and master the other dimensions, as happens for the first three, which seem innate to us. Since the dimensions are necessarily different conformations of the same known space-time, it is appropriate to turn our attention to the first three to know what relationship exists between them. This same relationship can, in fact, allow us to arrive at the subsequent dimensions. It is easy to understand that each dimension does not exist separate from the others, because only the set of dimensions represents real space, the physical entity that we call space-time. We start from the Euclidean description, taking into account, however, unlike Euclid, the first fundamental and immediate consequence of the curvature of space-time, that is, the substitution of the circumference for the straight line. The one-dimensional space-time S1 is that of the circumference. The two-dimensional space-time S2 is that of the spherical surface. The three-dimensional space-time S3 is that of the spherical volume. What is the relationship between the first dimension and the second, between the second and third, between the third and fourth, and so on? The spherical surface, thanks to the possession of the second dimension, allows the curvature of the first dimension of the circumference. This bending covers the spherical surface. Similarly, the spherical volume, thanks to the third dimension, allows the curvature of the first two dimensions of the spherical surface. This bending covers the spherical volume. Then the fourth dimensional space-time, S4, thanks to the fourth dimension, is what allows the change of curvature of the first three dimensions of the spherical volume. This, by varying its curvature, covers four-dimensional space-time. The directions of expansion and contraction are therefore the two opposite directions of the fourth dimension. This variation in the extension of three-dimensional space-time is the one already demonstrated by Einstein. We therefore understood that in order to discover the successive dimensions of space-time existing in nature, in addition to the first three noted for centuries, we must gradually configure an n-dimensional space-time, Sn, that allows the curving of Sn-1 space-time to n-1 dimensions. In the meantime, it is easy to become aware of the fourth dimension as we carefully reflect on the fact that thanks to the expansion of three-dimensional space-time, or which is the same as the shrinking of the observer, we can have the knowledge of an increasing number of new details, new beings, or particles that were previously completely invisible. Without the fourth dimension, we could not, in fact, have the magnification of the microscope or telescope, and we would simply have the visual enrichment that we obtain by approaching an object with the naked eye. At this point, I would like to point out a surprising fact, namely how the nature of numbers, in their unlimited extension, was a very ancient, unconscious, advanced knowledge of ours because it was capable of describing the expansion in the fourth dimension. To find the configuration of all the dimensions, and therefore of the forces expressed by them, it is necessary to describe a second fundamental and immediate consequence of the curvature of space-time, also unknown to Euclid. In fact, the non-existence of the straight line implies that even the radii of the circumference are curved. So what happens if we enlarge a given circle plus gamma having center plus c? On the other hand, what happens if we consider a circumference plus gamma with center plus c getting smaller and smaller? In the first case, the observer, enlarging himself, would see that the circumference is forced to invert its curvature, varying the magnification and shrinking, in correspondence with Im, until it becomes the circumference minus gamma extended as the plus gamma and having center minus c. In Im there would be a maximum circumference. The cancellation of the curvature in the maximum circumference IM is relative to the observer too, when he is unable to evaluate the curvature of the circumference. Therefore, the circumference that appears maximum to one observer does not appear such to another. Due to the presence of the two centers or poles, initial and final, we could call this phenomenon of magnification, inversion, and shrinking, and vice versa, bipolarity or bipolar inversion of space-time. This phenomenon leads to a conclusion of extraordinary importance for our knowledge. Bipolarity, being an immediate consequence of the curvature of space-time, must be present not only in the known dimensions, but also in all the unknown dimensions that we are looking for. The observation of the bipolarity of space-time is a great step in the research, and we can already draw a fundamental consequence. We know that every force is generated and described by the curvature of space-time. Therefore, every force must be subject to bipolarity. In each dimension, that is, a field of forces necessarily diverges from one pole and converges on another pole. Do we already have experience of bipolarity? Yes, because it is well known in the forces of electromagnetism, but we now know that it is also present in gravity and nuclear interactions. Let's go back to the second question. What happens now if we consider an ever smaller circumference? The observer, shrinking, would see that the circumference is still forced to reverse its curvature, changing the shrinking into enlargement in correspondence with I small m, until the circumference minus gamma coincides with plus gamma. In I small m, there would be a minimum circumference. Similarly, the maximum of the curvature in the minimum circumference I small m is, as explained, relative to the observer when he is not able to evaluate the curvature of the circumference. Thanks to the consequences of the curvature of space-time and the fourth dimension, it is now possible to explain, after 24 centuries, a precious jewel of human ingenuity, the famous paradox that sees a turtle always ahead of the very fast Achilles in the competition conceived by Zenon. With his impeccable reasoning, the great scientist of Elia already showed at that time the insufficiency of Euclid's three-dimensional geometry in the representation of the microcosm. Now we are very careful. When we describe dimensions, we describe together the forces associated with them. We have just clarified that in every dimension there is a force field diverging from one pole and converging at another, phenomenon due to the curvature of space-time. We now describe the dimensions, taking into account the bipolarity. In the first dimension, we pass from the absence of space-time of the point plus m0, the first pole, to the circumference of the space-time S1, whose development diverges from plus m0 and converges to the second pole, minus m0, center of gravitational attraction. Space-time S2 allows the curving of space-time S1. Due to the existence of the two poles, the curving of S1, diverging from plus m0 and converging to minus m0, occurs in the form of a helix that covers the spherical surface S2. This surface, thanks to the third dimension, curves, forming a star of helices, the one that, having the two centers, plus m0 and minus m0, we could define a bistar which covers the spherical volume S3 in 3 dimensions. In summary, each ray S1 of the bistar of spacetime S3 curves according to a helix diverging from plus m0 and converging to minus m0. Considering the bipolarity in gravity, we have come, as mentioned, to a fundamental conclusion. The gravitational attraction corresponds to the gravitational repulsion. That is, there must be the center of gravitational repulsion from which the force field derives to reach the center of gravitational attraction. Why don't we know the centers of gravitational repulsion? Because they reject matter, curve the light, and therefore are not visible. We have found that each new dimension n allows the curving of space-time, Sn-1. Thanks to the fourth dimension, space-time allows the curving of the first 3 dimensions, that is, the expansion and contraction of space-time, S3, the opposite directions of the fourth dimension. As the point separates the opposite directions of the first dimension, so the spherical volume separates the opposite directions of expansion and contraction of the fourth dimension. Considering the bipolarity, the spherical volume expanding from the particle plus m3 due to the curvature of its rays is reversed into spherical volume in contraction to the particle minus m3 and vice versa. Therefore, the existence of the fourth dimension implies the presence in nature of spherical volumes, particles which separate the opposite directions of expansion and contraction in the fourth dimension of the 3-dimensional spacetime S3, and therefore the opposite directions of the relative forces generated. The particles plus m3 that have an expansive force field outside must have a contractive force field inside. The particles minus m3 that have a contractive force field outside must have an expansive force field inside. These particles are obviously the electron and positron of which we have been acquainted for a long time. We can now repeat for the second triad of dimensions, 4, 5, 6, the same geometric development, the helical curving described for the first triad, 1, 2, 3, replacing the radius S1 with the helical bistar S3, in expansion from plus m3 and in contraction to minus m3. I called plus m3 and minus m3 these particles because, although they are generated by the opposite directions of the space S6, their 3-dimensional material volume belongs to the spacetime S3 and is the reference quantity of S3. It is the opposition of the directions of the second triad of dimensions, 4, 5, 6, the opposition of the directions of the electromagnetic field that allows the concreteness of reality, matter. As the points, separators of the opposite directions of the first dimension, are all equal, so the particles, separators of the opposite directions of the fourth dimension, are all the same. The presence of an M3 particle implies the presence of a pair plus M0 minus M0 inside it and another one outside it, that is, the expanding and contracting space-time S3. The external poles minus M0 repel each other, being of the same sign, but attract the M3, which belong, as explained, to the space-time S3. The external poles plus M0 repel each other, being of the same sign, and repel the M3 from which they are far away. We keep climbing the scale of dimensions. The spacetime S6 is that of the particles plus m3 and minus m3, electrons and positrons. The seventh dimension must then allow the curving of the pair plus m3 minus m3, which we call m6. Considering the bipolarity, the spacetime S6 expanding from the particle plus m3 due to the curvature of its rays is reversed into S6 in contraction to the particle minus m6 and vice versa. There must be particles in nature which separate the opposite directions of expansion and contraction of the pair plus m3 minus m3 in the spacetime S7, and therefore the opposite directions of the relative forces generated. The particles plus m6 that have an expansive force field on the outside must have a contractive force field inside. The particles minus m6 that have a contractive force field on the outside must have an expansive force field inside. We can then repeat the same geometric development, the helical curvature, described for the previous triad, substituting the plus m6 and minus m6 particles for the spherical volumes, that is, the plus m3 and minus m3 particles. In each m6 particle, we have two pairs of plus m3 minus m3 particles, electron and positron, one expanding, the other contracting. Due to the attraction and repulsion of positive and negative electric charges, the four particles must be located at the vertices and center of an equilateral triangle. Considering the areas in which the changes mutually cancel each other, three charges remain at the vertices, plus 2/3, minus 1/3, and minus 1/3. These, as you can see, are equal to the charged notes of the quarks U and D. One positron remains hidden by the other three particles. There are only two types of particles in nature corresponding to the characteristics of plus m6 and minus m6 particles, the neutron and the antineutron. In the antineutron at the center of the triangle, there is an electron. So far it is stated, as is known, that a neutron is composed of three quarks, a quark U and two quarks D, but it is not explained how fractional electric charges are born, nor does it explain how beta decay produces an electron charged -1, leaving a proton composed of two quarks U and a quark D. The quarks would inexplicably transform from U to D and vice versa. In the antineutron at the center of the triangle, there is an electron. The third triad of dimensions of space-time explains instead that there are four quarks in the neutron, one of which is hidden. They are the two pairs of particles plus m3, minus m3, electron and positron, the first in expansion, the second in contraction. Beta decay occurs when a loosening of the grip that tightened plus m6 to minus m6 at the boundary of the atomic nucleus allows the outer plus m3 particle of the plus m6 in expansion to move away from the nucleus. Then the positron placed in the center of the triangle moves at the vertex left free by the electron plus m3, which has moved away. Considering the areas in which the charges reciprocally cancel each other, three charges now remain at the vertices minus 1/3, plus 2/3, and plus 2/3, the charged notes of the U and D quarks of the proton. In beta plus decay, a positron is produced, transforming a proton into a neutron. It should be remembered that due to the bipolarity of space-time, the presence of a particle implies the presence of the relative antiparticle, as evidenced in the annihilation or in the production of particle-antiparticle pairs. Therefore, in the beta plus decay, an electron is generated together with the positron that allows the proton to become a neutron. The production of particle-antiparticle pairs confirms how the growth of energy is the growth of the curvature of space-time, which manifests itself in the particles of matter. Finally, remember that M3 are present in M6 particles in expansion and contraction, in neutrons and antineutrons. So the minus M0 particles that attract the M3 to themselves remain captured inside the M6, while the plus M0 repel each other away from the M6, from the atomic nucleus located around the celestial bodies. Before dealing with the dimensions of light and its fundamental importance, let us summarize what we have dealt with so far. The curving of the first triad of dimensions generates helical bistars extended from plus m0 in the expansion to minus m0 in contraction. That is, it generates the repulsive and attractive spacetime S3. The curving of the second triad of dimensions generates helical bistars extended from plus m3 in expansion to minus m3 in contraction. That is, it generates the repulsive and attractive spacetime S6. The curving of the third triad of dimensions generates helical bistars extended from plus m6 in expansion to minus m6 in contraction. That is, it generates the repulsive and attractive spacetime S9. The variation of the three-dimensional space-time demonstrated by Einstein is that in which, by changing the space-time S3, the diameter of the spherical particles M3 changes and consequently the size of the M6. Being made of these particles, we can experience this directly only in the growth of the observer from child to adult. For this reason, objects or environments appear larger in our memories than we see as adults. We instead experience the electromagnetic field, that is, the expansion and contraction of space-time S3 in the fourth, fifth, and sixth dimensions, outside and inside the M3 particles. What are the dimensions of light, i.e. the electromagnetic wave? It is generated, as we know, from the oscillating circuit when a particle plus m3 accelerates and therefore has an increase in extension in the fifth and sixth dimensions. This would lead to an increase in the extension S6, proceeding transversely to the motion of the particles. Then the part of the space contiguous to that, in which the forces vary, restores equilibrium, curving in the same dimensions in the opposite direction, as in the positron, transmitting the increase to the contiguous space. This gives rise to the phenomenon again, creating a chain of inversion, a wave, that is the six-dimensional entity Q6, known as a photon. This passes from the size of the electron to that of the positron. Its oscillatory nature, which instantly assumes and loses the state of matter, would explain why, although it has no resting mass, it nevertheless has momentum. A process analogous to the production of the photon Q6 in the dimensions 4, 5, 6 of the space S6 occurs in the triad 7, 8, 9 of the space S9. In beta decay, the electron emitted by the neutron accelerates in S9 space. The Q9 particle that is produced is erroneously called antineutrino, even though it is neutral, like the neutrino produced in beta plus decay. Let's go back to the photon. Thanks to this space-time nature, S6, thanks to its origin in the deep microcosm, the electromagnetic wave, composed of photons, expands from the microcosm into spherical waves, S6, until it meets a lens in the mediocosm, which converges these waves into a very small area, giving to the microscope the enlarged image of the body of the microcosm from which they derive. Therefore, we can have knowledge of an increasing number of new details, new beings or particles that were first entirely invisible, as if we were shrinking into the fourth dimension.